Hello, in this video, I'm going to use this. It's a 555 timer, so NE555P, and an Arduino. And really, the point of this is not so much a project about the 555 timer, but actually to use the Arduino as a way of measuring the timing of this chip. So recently I was wanting to make a project, so this is the end result, but I wanted to use a 555 timer to create like an external watchdog. So to create a 10-second signal and then off for 3 seconds and then on for 10 seconds. And so, you know, I could do the calculations, but I wanted a way to actually measure that before I put it into a big project like this. So what I decided to do was I hadn't really used a proto shield before, so I used a prototyping shield and a little mini breadboard. So you wouldn't have to use this. You could use any breadboard this size or bigger, but I decided I wanted to try this. Okay, so these shields, they plug into the Arduino right with your setup. And the cool thing is, like, if you want, you can take it apart, okay, leaving it all set up. I haven't set it up yet, but leave it, and then you could use this for something else. And then when you want to come back to the project, you can just plug it back in and everything is connected again. You don't have to connect to the individual pins. So for this project, I'm going to use the interrupt pin and the power from the Arduino to measure this chip and the timing of it. So if you look at this picture here, it shows a picture of the chip. And the labels for all the pins. So I won't go through all the function of the pins. I just want to point out a few things. So first of all, there is a notch at one end of the chip. And actually on mine, there's also a circle. And so that helps to determine which pin is pin 1. And then the pins are numbered down to pin 4 on the left, and then up pin 5 to pin 8 on the right. Pin 1 is the ground pin, so you need to connect that to 0 volts, okay, for power. And then pin 8 is VCC, so that you need to connect to the positive voltage, which in our case we're going to use the Arduino's 5 volts. There is a reset pin, pin 4 on the bottom left. We're not going to be resetting anything, so we're also going to connect that to 5 volts, just so it doesn't reset while we're using the chip. And then pin 5 is the control voltage pin, but we're not going to be using that, so we're not going to connect that to anything. Okay. This is the circuit that we're going to use for a 555 timer, and this setup is called the astable operation, or sometimes called astable multivibrator. And so this is how we're going to set up the connections. So pin 1 goes to ground, like we said. Pin 8 goes to the 5 volts. And then here's pin 4. It's not connected to any of these, but it is connected to the 5 volts. And then if you notice on the right side, there are 2 resistors, resistor A and resistor B, and then a capacitor. And so what this actually does is the capacitor gets charged up from the 5 volt pin, but it has to go through resistor A and resistor B to charge up. And during this time, the output pin is actually putting a signal at 5 volts. Okay, that's the high signal. Okay, 5 volts here. Then at a certain voltage of the capacitor, it begins to discharge. And so then the current now comes out the capacitor through resistor B, not resistor A though. And so during this time, the output pin now is at 0 volts. And at a certain voltage, when the capacitor drains down to a certain voltage, then the cycle begins again. And it starts charging up again, and the output pin at that point goes high again. And this goes back and forth, high, low, high, low. And so on the output pin, you get this basically a square wave. Okay. Now the duration of sort of the period, I guess you could say, of the output pin going high depends on how big resistor A, resistor B, and the capacitor are. And then the time for it to be low, so the low period, so let's call it time 2, T2, again, depends on the capacitor and the resistor. And so in the project that I was working on, I wanted, time 1 to be 10 seconds and time 2 to be 3 seconds. And so I could do the calculation, but I wanted this to be able to test out to make sure that I had the right components. So I'm not going to be doing that in this video or this setup, but I just want to show you how it is I use this to help figure out what components I needed for this timing. And so actually you can calculate this. So here are two equations for this setup. And one equation is to calculate the high period and one for the low period. And so like I said, for the high period, it depends on the resistor and the capacitor. So the formula is 0.7 times the sum of both resistors times the value of the capacitor. Okay, and that will give you a time in seconds that the output pin is high at 5 volts. Similarly, for the low period, there is an equation 0.7 times only resistor B times the capacitor, right? And so that'll give you a low time in seconds. So you can see the low period can never be longer than the high period, but you can play around with the resistors and the capacitor to modify the different high and low periods. And just to note, so our period, the units will be in seconds, but our resistor values have to be in ohms, which is quite small. And then the capacitor has to be in farads, which is quite big actually. So let me show you an example. So if both resistors are 10,000 ohms each, and the capacitor is 10 microfarads. Now a microfarad means a millionth of a farad. So for example, 1 microfarad would be 1 times 10 to the minus 6. So 10 microfarads is 10 to the minus 6 farads. Okay, so in other words, this equals 0.00001 farads. Okay, very small. So if we use these values and put them in our equation, so 0.7 times 10,000 plus 10,000 or 20,000 ohms times 0.00001 farads. Okay, so if you put that into a calculator, you'll calculate that the high period should be 14 seconds. And so 0.14 seconds. So for 0.14 seconds, the output pin should be at 5 volts. And then the low period is 0.7 times 10,000 ohms times 0.00001 farads. And so the low period should be 0.07 seconds. Right? And so, I mean, there's always some variability in the components where it's not exactly what you want. And, depending on your setup, things may not come out exactly what you calculate. And so that's why I wanted to try this setup and figure out if I had the right components. So let's set that up. So here's our setup. So like I said, pin 1 is ground. And so these are the digital pins of the Arduino, right? So all of these are connected to all of those, which are connected to the chip in the Arduino. And so after the digital pins, there is an actual ground pin here. So why don't we use that? So you can use, regular jumper wires if you want, but I find it easier when you're demonstrating to use these kind of wires. So there's ground right there, and let's connect that to pin 1. Okay, and then pin 8 we're going to connect to our 5 volts. So this first one here is V in, and then there's 2 ground pins, and then that one there, the fourth one is 5 volts. So let's plug that in there. Okay, and so those kind of help hold this breadboard in place. It's not too secure, but it does kind of help. So again, here's pin 1, pin 8. We said that pin 4, the reset pin, we're not really going to use, so we're going to connect that to 5 volts. So here I'm just going to put a wire over top. Okay, so anything in that row is connected to the 5 volts. So now pin 4 is connected to 5 volts. So in our example, pin 8 is connected to pin 7 with, this is a 10,000, let me show you here, 10,000 ohm resistor. This is our, I should show you what I'm going to work with here. So this is resistance. Here it's in ohms. Right now it's not measuring anything, but here's one resistor. So it's just under, so 9.9, so it's just under 10,000. Okay, so there's one. This is our other one. It's basically the same. Okay, and it's 9.9 thousand, so basically 10,000. The capacitor I plan to use is this one here. Whoop, dropped it. So I don't know if you can see that. It's not focusing. There, 10 microfarads, right? That little mu is for micro, 10 microfarads. It says 50 volts, so it can take up to 50 volts, but we're only using 5 volts, so that's fine. So let's change this to capacitance, to measure capacitance. And these kind of electrolytic capacitors, they have a negative and a positive, so we're going to connect the black to the negative. So in the circuit, you have to pay attention to that. You don't want to connect it backwards because these can pop and destroy themselves if they're in wrong. So that's just over 10 microfarads. Okay, so we're going to use that for our timing. So let's move this out of the way. So our capacitors are the same. Sorry, our resistors are the same. So let's connect one from pin 8 to pin 7. So that would be our resistor A. Okay. And then there's one connected from pin 7 to pin 6. Okay. Now, so they're connected in the middle to pin 7. This one connected to pin 6. We're also going to connect the capacitor. But what I'd like to do is actually put it down further down on the board. So I'm going to connect with this further down. So now this is connected to pin 6. Okay, so now anything in this row now is connected to pin 6 and this resistor. Okay, and if you remember, the other side of the capacitor has to be connected to ground. So I want to connect a wire from ground all the way over here. So we'll use this one, black wire. So it's in the same row as pin 1, and then we'll just kind of bend it here. Put it right there. Okay. So now when I connect my capacitor, again, the negative side, the side with the shorter lead, is going to go to ground. Okay, ground, just like, it's not going in, just like that. Okay. So I want to connect this side of the capacitor, the positive side, to pin 2. So I'm going to use this green wire, and let's connect it to pin 2 here. And then again, bend it. And we don't want it to connect it to ground. We want to connect it to there. Okay. And so lastly is our output pin. So that's pin 3. And there's nothing connected to it right now. So I'm going to take this jumper wire. I'm going to put it in there. So pin 3. And then I need the Arduino to monitor it. So I'm going to use an interrupt, and so the first interrupt pin on the Arduino is pin 2, D2, okay? And so that there is my setup. Okay, ground, and then this is connected to the positive end of the capacitor. This is the output, pin 3. Pin 4 is a reset, and so we connected that to the 5 volts. Pin 5 here is the control voltage. We're not using that, so nothing's connected to that. Pin 6 is connected to this capacitor on the positive end, and this this end of the resistor. Pin 7 is connected to these both resistors, and then pin 8 is connected to 5 volts as well as this end of the resistor. Okay, and so that's our circuit all set up there. So now let's look at the code. So this is the code I want to upload to the Arduino. So I have a couple of variables that are Boolean, right? So they can be 1 or 0, and we're going to start them off at 0. And one is called the state, or just state. So I need to know the state of the output pin of the 555 timer, and then the other one's the last state, so the previous state. And then I need a couple of variables to measure time. So what is the time, the current time, so meaning when it just changed state, we're going to keep track of what time that was. And then last time, so the time that it previously changed the state of the output pin. So as the output pin goes from high to low and low to high, we're going to sort of use these as timestamps. The current one and then the previous one. And then we have one variable, it's a float, and it's the difference between them. And so that's how we're going to calculate how much time is it high and then how much time is it low using these variables. We're going to print our results in the serial monitor, and usually it's 9600, but I put up to a higher baud rate here, so 115,200. So make sure that when you open your serial monitor that it's set at the same baud rate, okay? And then, like I said, we're going to use an interrupt. So attach interrupt. I'm going to use the first one. So 0 is the first one, 1 in the first interrupt, 0 is the first one, interrupt 1 is the second one. So that's just how they numbered them. But this one corresponds to pin 2. And so we've connected our output pin to pin 2. And so when the state of pin 2 changes, so meaning going from high to low or low to high, then we're going to run a function called timestamp. Okay, so let me just show you what timestamp is. So very short. So when this function is called timestamp, then we're going to record what we see on pin 2. So if it's high, like a 1, then we're going to make state equal to 1. Okay? Or if pin 2 is low, meaning 0, then state will be 0. Okay? And then we'll update also our current time, and we'll use the microseconds function that the Arduino, this is an Arduino function, comes with the Arduino IDE. Okay? And then, so that will be called, every time that pin 2 changes, it will call that function, regardless of what it's doing. Okay? And then in the loop, so this part goes over and over again, as long as the Arduino has power, if the state, okay, does not equal the last state, so meaning the state has changed, and these aren't equal anymore, then this section of code will run. Okay? So this line says if state. So this means if the state is 1, if it's high, then this will say low 4, so the amount of time that the output pin has been low. Or if it's not, so if the state is 0, then it'll print this one, that it's been high for. And so this will tell us how long the pin was high. And then we do the calculation, whatever the time difference is. Okay, so the current time minus the last time, and because these are in microseconds, we're going to divide by 1,000,000, and that'll give us an answer in seconds. So time difference will be in seconds. We update last time and current time. Sorry, we update last time by making it equal to the current time, and then we just print what is the time difference and then our units in seconds. Finally, we update, so we make last state now. We change it, so now these are equal, and then once state is changed again in our interrupt function, then it'll print again. So as the Arduino is going through this loop over and over and over, it won't keep printing these numbers. It will only print whenever the state changes, and so the current state doesn't equal the last state. Okay, so hopefully, I know that makes sense, but let's connect the Arduino now. Okay, and so we want Arduino, and it's on COM port 9. That's good. And so let's upload. So it's compiling. Okay, I always get this error, but it's nothing. And it's done. So now if we open the serial monitor, and again, you want to make sure that this is the same baud rate. But here is our result. So if you remember from our example, we said that the high period should be 0.14, because here it says 0.15, and the low period is 0.07. So pretty close to what we got, not according to this, entirely the same, but actually that's quite close to what we got, right? And so then knowing that now, you can start changing these resistor values or the capacitor value, and you can monitor how long the output goes high or it goes low. So now let's try adjusting the high period and the low period by adjusting these different resistors and this capacitor, right? So right now we have 10,000 and 10,000 ohm resistors and then 10 microfarad capacitors. We also have our serial monitor running, and you can see we still have the 0.14 seconds for the high period and 0.07 seconds for the low. Okay, so let's keep that going. So we have some other capacitors here and some resistors. So this capacitor, I don't know if you can see this. Let me zoom in. Okay, so it's 4.7 microfarad. Okay, so basically half what we already have on the board. So let's set that down the side here. This one is 22. Okay, so about double what we have on the board. And then this one is 100 microfarad. Okay, not the biggest one I have, but I don't want to make this video too long. Okay, and then zoom back out here. So we have those three, and then we have these resistors. So let me show you what we have here. So bringing back our multimeter, set it to resistance. So this one, actually this one's the same, so we won't use that one. But here I have a couple. So this one is 4.7 kilo ohms, so 4.7 thousand ohms, right? So about half of what each of those resistors are. And then, so less, and then this one is one of the bigger ones that I have. So about 1 or 0.99 mega ohms, so million ohms. Yeah, 1 million ohms there. Okay. And so for my project that I mentioned earlier, I ended up using resistor values, like one of them was the 1 mega ohm and then 400,000 ohms to get the values that I wanted. And so that's why I created this, was to actually help figure that out, or just to even confirm. Okay, so here we have the 10 microfarad. And so again, if we increase the capacitance, so here's 22, then we'll increase both the high period and the low period. So sometimes when I take these out, it freezes it, but let's try. So putting this in. There, right, and the short lead goes on this side close to ground. And if you look at the serial monitor, we have in fact doubled our high period and our low period. Okay, cool. Okay, so that was 22. This one is 100. So basically this should be 10 times our original 10 microfarad. So we should expect high periods over a second, like about a second and a half. Right, and again, make sure the negative is on the side close to ground. So if we look at the serial monitor, we do in fact have a high period of 1.4 seconds and a low period of 0.67. So yes, 10 times higher. Okay. And then last but not least, we have something smaller. So this was 4.7. So this is about half of what we started with. And again, making sure the short lead is on this side. And now you can see the serial monitor is moving quite faster. And that's because our high period and a low period are basically cut in half. Okay, cool. Maybe we'll go back to 10. Yeah. Okay, so this is 10 microfarad. Let's move those out of the way. And so now let's try changing some of the resistors. So if you remember that the capacitor is charged up through resistor A and B, and during that time the output is high, right, the 5 volts. And then after that the capacitor discharges through resistor B and the output is low, right? So if we change this resistor, we'll affect both the high period and the low period. Or the high period, but we won't affect the low period. Sorry about that. So if we change resistor A, okay, so we go from the pin 8 to pin 7. Let's separate that a little bit. Okay, and so remember this is about half of what we had before. And our high period has now reduced from 0.14 to 0.11, but our low is still 0.7. Okay, because the low is affected only by resistor B. Okay, so let's put that back and let's demonstrate that. One thing I found with this is, so this is back to 10,000 each. So let's change resistor B. One thing I found when setting this up was that it often took several cycles for the times to stabilize, where they actually ended up being consistent. So now we have the 4.7 for resistor B. So now we should have reduced our high period and our low period. Right, and so that's what we see. So actually 0.09, so it's even less than the 0.11. And then our low is 0.03. Okay, and so you can put in resistors as big as you want, or a combination of resistors, and get really big times if you want. Okay, so let me put this as resistor B. So our last example, so 1 million ohms. So I'm going to put it in resistor for resistor A. So now our high period should be quite long. Okay, and if you look at the serial monitor, you'll see that it does take some time before the numbers stabilize. Right, and so this is one thing I learned actually from this setup. It's actually pretty close now. They're all about 7.47, 7.48. Okay, but there were actually larger changes when you get larger resistors. Okay, so I'm gonna end this video here. There's some other things I want to show you, like I did find that using this, I could actually show when you combine resistors and capacitors, you know, in series and parallel, and then resistors in series and parallel, you could actually show how they work on there. The other thing is you can actually measure the voltage with an analog pin and see what does the shape of these, of the output trace, and what charging and discharging the capacitor look like. But I think I'll save that for the next video.